Welcome all of you. At the outset, I express my sincere thanks to the viewers and the valuable subscribers of my previous video on aromaticity. Now we will see the introductory aspect of photochemistry in this video. Photochemistry is otherwise called light-induced chemistry. What is photochemistry? It is the study of chemical processes that occurs due to the absorption of light. Now we'll see some basic terms involved in this. Photon. Photon is the smallest discrete amount of light or single quantum of light, and this is the basic unit of light. So according to the quantum physics, photons are zillions of tiny packets of light. So in general, we can point out that photon is nothing but smallest amount of discrete amount of light. Simply, it is a single quantum of light. Next, ground state. Ground state is the lowest energy state. The energy of the ground state is 0 point energy. Next, excited state. So excited state is any state with energy greater than ground state is called excited state. Now we will see the quantum of radiations. It is nothing but multiple photon emission from a charged particles is called quantum of radiations. Next, singlet. Singlet is the molecular electronic state in which all electron spins are paired. So that is simply called as an singlet, or electrons are paired in ground state level. Next, triplet. It is one set of electron is unpaired. That is, the excited electrons is no longer paired, hence parallel spin. We'll see some definitions. Photochemistry is the study of chemical reactions twisted directly or indirectly by the radiation focused between visible and far UV region of electromagnetic radiation spectrum. That is 800 to 200 nanometers is called photochemistry. So I have collected and referred various textbooks and various authors. They have put forwarded some various aspects of the photochemistry. So I have given you here the collection of their various definitions. Next one, the schedule of chemical processes initiated by the action of light is called photochemistry. So in other words, the study of chemical reactions may occur under the influence of visible or ultraviolet light is called photochemistry. And photochemistry is the study of chemical effects of radiation primarily by visible and ultraviolet and direct creation of radiation of chemical transformation. And photochemistry is the study of chemical reactions resulting from the revelation of light radiations. So in the wavelength point of view, 2000 to 8000 Armstrong units of wavelength. If it is involved, that is your photochemistry. Photochemistry is the branch of chemistry related with the chemical effects of light. In general, to describe a chemical reaction initiated by the absorption of ultraviolet wavelength from 100 to 400 nanometers, visible light from 400 to 750 nanometers, or infrared radiations from 750 to 2500 nanometers. Now we will see some basics on photochemistry. So in general, what happens now in the case of during the chemical reaction after absorption of the radiation, whether the chemical bond is broken or new bond is formed, so which may be taking place by transfer of the charges within the molecules or among the molecules. So that the chemistry of bond forming and bond breaking and charge transfer within or in between the molecules upon induced by light is also called as a photochemistry. A photochemical reaction occurs by the absorption of electromagnetic radiation to produce electronically excited state. So upon excitation, what happens that the electronically excited molecule give rise to the products of chemical reactions. So which leads that a ground state level, that is the minimum energy of the molecules presence there, can uplifted themselves to the higher level of energy, which is called as an excited energy level, that is the higher energy level, which is called as an excitation. So simply we can call that the process of uplifting molecules from ground state to an excited state is called excitation. And what is electromagnetic radiation? So electromagnetic radiation is energy which is transmitted at the speed of light through oscillating electric and magnetic field. Sometimes the question is coming there, like what happens to the electromagnetic radiation, so how far it may be hazardous and harmful to the human health. So according to the literature, there will not be much effect, or simply we can say there is no evidences to conclude that the exposure of low level of electromagnetic radiations is harmful to the human health. So of course there will be a excess level of the electromagnetic radiations will leads to lot of human hazardous health hazards is also expected. Now we see the fundamentals of the photochemical laws. So generally photochemistry, in sense, if suppose anybody pointed out, we should be able to recall the scientist Grotthuss-Draper, Stark-Einstein, Beer-Lambert. All these great scientists are coming to the picture. First we will see the Grotthuss and Draper's law. So Grotthuss is a Theodor von Grotthuss in Australia, in Russia, and Draper, John William Draper of USA, independently formulated a law according to which rays are chemically active that are absorbed by reaction mixture. So simply point out that any reaction, if you are going to come across, the reaction mixture is able to absorb the light. So this is the point they come across, and we can point out that Draper, a person is famous nowadays. We can able to see the passport size photo or portrait form of the photography. This Draper is the very first person who has developed and introduced this portrait form of the photography. Now we'll see the Grotthuss and Draper's law. So Grotthuss-Draper's law directly relates the chemical transformation upon absorption of light, or simply light must be absorbed by the chemical substances in order to take place a photochemical reaction, or a light which is absorbed can effectively create the chemical changes. So all the point of view, different authors they have pointed, but this the law is simply says that upon absorption of the light there will be a chemical transformation takes place. Any chemical changes takes place upon the absorption of light. Next greatest persons are Stark and Einstein. Stark-Einstein law, which is otherwise called Photo-equivalence law, which has contributed by Jonas Stark of Germany and Albert Einstein. Both of them also independently they have pointed out this photo-equivalence law. According to the Stark-Einstein's law, for each photon of light absorbed by chemical system, only one molecule is activated for the photochemical reaction. Or otherwise simply we can say that every one molecule participating in a chemical reaction induced by contact to light absorbs only one quantum of radiation causing the reaction. So simply point out that in any kind of the various amount of photons may be emitted during that particular part of the reaction, only one molecule is activated, and that too one quantum of radiation is absorbed by the molecule, so which is responsible for the entire reaction. So in the primary process, which is nothing but the immediate absorption of light, every one reacting molecule is activated by one quantum of light. So this is the Stark-Einstein's law. And there are two photochemical processes is taking place. First one is the primary process, is nothing but absorption of light is the primary process, and subsequent chemical transformation taking place is the secondary process. And we will see the Beer-Lambert's law. Lambert in 1760 has pointed out that identical fractions or equal fractions of incident radiations are observed by consecutive layers of equal thickness of absorbing substances. So he has pointed out that equal fractions of incident radiations are observed by a consecutive layers of equal thickness of absorbing substances. So according to the Beer and Lambert's, both of them put forward their theory. Equal fractions of incident light are absorbed by the layers of the solution with equal concentration and identical thickness. So they come across with that A equal to epsilon Cl. A is the absorbance and E is the molar absorption coefficient, and C is the molar concentration, and L is the optical path length. Now we can able to see once the photochemistry the term is given, after the photochemical laws we can able to recall the Jablonski diagram. So Jablonski diagram is created by Alexander Jablonski, a Polish physicist who was having a research interest of molecular spectroscopy and photophysics, and even nowadays he is known for Jablonski diagram. So I have collected from some of the sources available from Wikipedia. Now we will see the chemistry of excited molecules based on the Jablonski diagram. So whilst we can see the diagrams here, there are S stands for the singlet and T stands for the triplet. So what happens now, a molecule which is absorbed some light, some photons, what happens now, that absorption of this light will responsible for the ground state to excited state. So which is called as S0 to S1, which is called as a photon absorption. And internal conversion, intersystem crossing, vibrational relaxation, fluorescence and phosphorescence, all these terms have been given in this Jablonski diagram. So what is internal conversions means? Now we can see that a molecule is started exciting from S0 to S1, and sometimes it may take some relaxation, that's a vibrational relaxation takes place, and come back to the ground state level, so that the S1 to S0, which is called as an internal conversion. And this happens not only with your S0 to S1, S1 to S2, S2 to S3, all the category, there will be possibility of interconversion is taking place, that is S3 to S2, S2 to S1 and S1 to S0. Now the inter-system crossing. So of course spectroscopically we can say that some of the forbidden transitions are there. Even then these transitions are considered for more interest for their transformation. So the inter-system crossing is nothing but the transformation from S1 to T1 level. And of course we can able to discuss all those things in some more slides also. The fluorescence is nothing but S1 to S0. And if suppose triplet to singlet is coming, that is called your phosphorescence. Now we can see one by one in detail. Once it is formed, that's a molecule started excitation, absorption of the molecule, and chemical reaction is transformed. And once it is formed, the excited singlet and triplet states will either undergo photochemical changes or sometimes loss of their excited energy, either by radiative or non-radiative chemical processes. So which can responsible for the intermolecular energy of transfer of the energy. So in general, almost all organic molecules in their ground state are singlet only, with all the electrons are spin paired. So that's why we have given these things in a singlet in a terms involved definitions also we have pointed out at this time. Singlet states are the ground state level with electrons are spin paired. And what happens now, this absorption of the light takes place, the molecule is just excited to first level, which is called as in first excited state, which is called S1 state, that is S0 to S1 it is going. And during some process I have pointed out that the vibrational relaxation, which is nothing but a non-radiative process, the process of coming down by a molecule from the top of the S level, singlet level, that's S1 or it may be S2 or S3, it may be to the top level, that is S3 to S2, S3 to S1 and S1 to S0. This vibrational level, which is called as an excited vibrational singlet level, to the bottom of the vibrational level, that is SN vibration level of the ground state level, as well as we can point out that in the triplet level also the vibration level to the excited level to the ground state level may also be come out, which is called as an vibrational relaxation. That's the molecule, once it is absorbed to the ground level to the excited level, after that which may slowly come back to the ground state level. That's the point they have come across with the vibrational relaxation. So S0 to S1 is the absorption of light, which is otherwise called photon absorption. We know that S0 to T1 level is a spin forbidden. Now we can point out that the S1 excited state has a very short life, that is 10 to the power minus 8 to 10 to the power minus 7 seconds. Therefore, the excess energy possessed in the singlet state can be dissipated by the following processes. So which is otherwise called as S1 level to S0 level, which is called as an internal conversion. So this internal conversion takes place in the very fast process, extremely fast, which is takes place in 10 to the power minus 14 to 10 to the power minus 11 seconds. The first excited to ground level by the emission of photon. So it's a long wavelength than the original light, which is called as an fluorescence. So if it is an fluorescence, all general interconversions, and we can point out with the fluorescence is 10 to the power minus 9 to 10 to the power minus 6 seconds, which is ultimately fast one. And another one, S1 level to T1 level, which is called as singlet to triplet. So that the system is going singlet to singlet or triplet to triplet. Likewise, singlet to triplet is going. So that this is actually slow process but energetically useful one However, spectroscopic point of view, we can point out that this is an spin forbidden process. Of course, for organic compounds, the two aromatic compounds which contains a carbonyl group can possess this particular type of the chemical reactions and possess the inter-system crossing. Inter-system crossing can take place with high energy of efficiency, and T1 can exist longer period of time, that is your 10 to the power minus 3 to 15 seconds, than that of the singlet state level. Singlet state, of course, we have pointed out in the top of the slide, 10 to the power 8 minus 8 to 10 to the power minus 7 seconds. So S1 can undergo chemical transformations like decomposition and isomerization, and lot of chemical changes, transformation can be possible. Triplet to singlet state of transformation takes place by the emission of photon, which is called as an phosphorescence. So relatively, likewise, the fluorescence, this is also a fast one, and this is 10 to the power minus 11 to 10 to the power minus 6 seconds. This is also extremely fast, and T1 can transfer its electronic states to the another molecule and convert it into S0 level. And the process of triplet state energy transfer process is called photosensitization. Simply, process of triplet energy transfer process is called photosensitization. Similarly, the excited state species can emit the light, so which is simply called as an luminescence. This is a radiative process. Of course, there are three possible type of the fluorescence are there. That is fluorescence, phosphorescence, both are photoluminescence process triggered by the light. But you have chemiluminescence, glow is caused by the chemical reaction. Of course, we can know that bioluminescence is also there, but we are pointing out only the absorption of the light and what kind of chemical transformation is taking place. The excess of vibration energy is lost by the collision with the molecule, which is called as an vibrational relaxation. So that is either the level of we can point out that your S0 to S1, S1 to S2, S2 to S3, or otherwise we can see that T1 to T2, T2 to T3, T2 to any higher level. Once it come over there, the molecules presence there, once it's absorbed to go to the higher level, within that part the molecules get collusion in such a way that the molecule is, once it is colluded, the energy is getting lost. Based on the loss of the energy, the molecule is getting back to the ground state level, which is coming to slowly to the ground level, which is called as a vibrational relaxation. So very simply we can point out that simple example, that if we want to cool in a hot vessel, what we are going to do, we are taking the hot vessel in a cup of water. So after a while, what happens now, this particular hot vessel is become cool, but the cup of water becomes a hot. So this is the process of how the vibrational relaxation takes place. Now we just to summarize the Jablonski diagram. Transfer of energy by the absorption of light takes place. Absorption of these lights brings to S0 to S1 level, which leads to the photon absorption, and we can come across with the various processes like internal conversions, S1 to S0. We can point out this is otherwise also fluorescence, and intersystem crossing, S1 to T1 level, vibrational relaxation, the molecule once is excited and slowly come back to the ground state level, and phosphorescence is your T1 to S1 level. So all these summarizing points can give you an idea with your Jablonski diagram. So based on the things, some of the references I have pointed out, that some of the valuable books I have mentioned here. Based on these books, I have done the photochemistry points, the basics or introductions of the photochemistry on that. and we will see some more aspects of that Norrish type 1, Norrish type 2 reactions with the detailed examples in forthcoming slides. Thank you once again for watching this video. Thank you, one and all.